why do you guys think the people in the video got stronger? Yes, sir.
You said the drink is supposed to make you stronger, so people's mindset got tricked and instead they just put more effort.
Yeah, I like that. So I'm going to ask you to repeat that one more time so I can write it down. So you said the drink is supposed to make you stronger.
So the people's mindset got tricked.
People's minds got tricked.
And instead they just put more effort.
And instead they just put more effort in. I like it. Obviously, from what they explained in the video, the drink has no strength enhancing powers whatsoever. So this had to be coming from the person themselves, whether they put more effort in or whether they just tried harder, they believed in themselves. This is the power of the placebo effect. If you believe something, it does have a measurable impact on outcomes. When people talk about the power of positive thought or like self-actualization, imagining yourself doing something, doesn't mean you're definitely going to succeed, but it does have an impact on the outcome. Thinking positively, thinking in these ways does show results. All right, so what do you guys think about Mrs. Gallus's setup here? Her initial plan. She's going to measure the initial pulse rate, give each student some caffeine in the form of Coke, wait for a specified amount of time, measure the final pulse rate, and compare the final and initial rates. Yes, sir?
I said she should find a difference between initial and final heart rates, and also people have different resting heart rates. So she should take that into consideration.
Yeah. So people have different resting heart rates to begin with. Does anybody else see any other problems other than just people have different resting heart rates? Joan?
There's no specified selection. Like, it doesn't say where we're going to find students around.
There we go. So there is no defined way. To select students. I saw a couple other hands up. Grayson?
I was thinking if they already had caffeine.
What if they already had caffeine? Josh, did you have your hand up?
Yeah. They could have done some before drinking caffeine, like worked out or something. Got there.
They might have had conditioning that morning, right? Like maybe they didn't have caffeine, but they did some other activity that got their heart rate up. So I'm just going to kind of tack this on to the end here. Or other activity that raises heart rate. Yes, ma'am.
There's no control group.
There's no control group. Why does that matter? Yes, no control group. We need this for comparison purposes. Maybe, I don't know, but maybe just throughout the course of the day, people's natural cycle, your heart rate raises throughout the course of the day and then lowers. I really don't know. Yes, ma'am.
I was gonna say, what if they're like tolerant to caffeine?
What if they're what?
Tolerant to caffeine.
Tolerant to caffeine. All right, I've kind of filled up my screen. You guys might have more things other than that, but I think I'm going to stop copying things down at this point just because I simply ran out of room. So question number 3 on here asked you to go back and to list solutions for these issues. So what kind of solutions did we come up with? What kind of solutions do we have? What could we do to control for people having different resting heart rates to begin with? We could have multiple groups. How would I make sure that I didn't end up with all the people that just have naturally higher resting heart rates in a group?
But you could separate, like, put the different heart rates in one group. Like, you could categorize the heart rate.
Categorize their resting heart rates?
Yeah, like, I don't know heart rates for real. So, like, put one. How do you do heart rate? What is it, like 120 or something like that?
Honestly, I don't know what the average resting heart rate is. I knew it at one point because I've done activities like this before in other classes, but it's been like 3 years since I looked it up. So my brain doesn't retain those numbers. But I'm sure you could, like, if you measured everybody's heart rate, you could kind of say, like, okay, we could do quartiles or something like that. Yes, ma'am.
You can also separate like men and women differently, presumably differently.
So we could go based on gender assignment or gender expression and kind of. So what I'm hearing both from Josh and from Joan is that we could use some kind of stratified method to divide these up. How do I still make sure, like, even in this stratified way of doing it, how do I mean, because we've got several different things that we feel are outside of our control here. What could we do? And I'm not disagreeing with anything that's been proposed. I think these are great ideas. What's some way that we could try to make sure that as I've got these different groups going on, all these different uncontrollable or unknown variables kind of get spread evenly between my groups? What's some way that I could account for that? We could randomly assign. I could have every volunteer that has agreed to participate, I could give them all a number. I could use my random number generator and just start assigning them to different groups. If it is chosen randomly, then the chances that I have evenly spread out all these other things that I can't control for means that the only real substantial difference between these groups should end up being the condition that I'm exposing them to. So random assignment takes care of quite a few of these. All right, so random assignment takes care of this one. It takes care of this one. It takes care of this one here. And if we do random assignment, that kind of takes care of this control group with this idea that we'd need at least 2 groups. One that gets caffeine and one that gets no caffeine. All right. And that kind of addresses this one a little bit. We might take volunteers, but then if I randomly assign them from there, we would still be able to kind of generalize our findings, or we could at least make claims about this group of people, and then if I repeat that over and over, I might be able to generalize those claims out. What do we do about people that just like they know they're getting soda, and so they have beliefs about that, like we saw in the video? Yes.
If everyone's soda before is caffeine-free.
Yes, I love that. We could control for that placebo effect by maybe having a third condition here that is caffeine-free soda. That idea where our participants all, as far as they know, receive the same treatment. Everybody's getting soda. It looks the same in the little cup. You've been told it's this energy drink or this caffeinated drink. Maybe you don't know it's Coke. Caffeine and caffeine-free soda. This idea right here, let me try to circle it in a color that's going to stand out. My participants wouldn't know which one they're getting. That's called blinding. Blinding. Participants don't know if they get the caffeine or the caffeine-free. We do blinding to help us control for the placebo effect. There are certain circumstances where it makes sense to do something called double blinding, where not only would the participants not know which one they're getting, but the researcher that's actually interfacing or interacting with the participants also doesn't know. And we do this because over time what we figured out is if the researcher knows, especially if they really, really want the outcome to come out a certain way, they might unintentionally be more encouraging of one group than another. Maybe their overall demeanor is just more excited, and that kind of bleeds out through this. If they don't know which group received what, they are going to walk in with kind of the same level of expectation. We see this a lot happen in different trials for medications, especially if a company has put a lot of money into developing a new medication and they really, really, really want this to work. It's really important that the researchers not know which participants received the actual treatment and which ones got that placebo. I think these are some great ideas. How could we design an actual well-designed experiment to test the effect that caffeine has on heart rate? You guys have come up with some great ideas. Let's formalize it. Yes, ma'am.
So I only use caffeine and no caffeine, but I mean I can put the caffeine-free in it. So I said like you can choose like 30 students, and you can put numbers 1 through 30 into a hat. Have each student draw a number. This was for the two, but I said evens consume the caffeine, and then the odds don't, and then measure the initial heart rate before they take it, and then wait. I said 10 minutes, and then remeasure.
I love it. I love it, I love it, I love it. So 30 students, we get our random assignment. I love the way you described how you would randomly assign, where you've got them just drawing numbers out of a hat. That would be similar to a random number generator. You said evens go to this group, odds go to that group. If we decided to split it into 3 groups, because I thought that was a great idea that came up as we were talking about this together, maybe 1 through 10 is in group 1, 11 through 20 is in group 2, 21 through 30 is in group 3, something along those lines. So we could split them into 3 groups here. We'd have 10 students in each group. And I'm just kind of doing it mapping style. You can write it out in words, that's perfectly fine. Remember, you can do either one of these as you are describing or designing an experiment. So 30 students, we get our random assignment down. Group 1, Group 2, Group 3. For everybody, we measure. And then one group gets caffeine. Second group, we could measure, and then they get caffeine free. Third group, we measure, and they get nothing. And then bring them back together at the end and compare heart rates again at the end, right? I love it. That's a great design. All right. We are ready to talk about our big ideas here. So we always need to have a control group because we need to have some baseline data. Depending on the type of study, sometimes our control group gets nothing, sometimes our control group gets a placebo, sometimes we have both types of control groups so that we know just what the measurable placebo effect is. But we need a control group to get some baseline data for comparison. And then we've got blinding. Single blind is when the participants or the subjects don't know which treatment they are receiving. Double blind is when the subject and the experimenter who is interacting with them don't know which treatment they're receiving. Placebo effect is just when a fake treatment actually works. You have this belief and you see results. Super important to randomize our group assignments, because that's how we can try to control for confounding variables. So we're going to label all the participants, then we're going to randomize that. Numbers in a hat, pull them out lottery style, random number generator, and then we assign them to groups based on that. Key principles for experiments. We have to be able to do comparisons, so 2 or more treatments. And by treatments, one of those treatments might be that you don't get the treatment that the other group got. So you have to have your control and then at least one other condition. Have to have random assignment. We need a certain level of control, so we want to keep all the other variables except the treatment constant. So for example, in the heart rate problem, I'd want to make sure that I am waiting the same amount of time for each person. They're in a room that's the same temperature, same lighting level. If I've got music playing for one set of people, I need music playing for everybody else. I want to keep everything about the environment and the testing conditions exactly the same. I want to control as many of those confounding variables as possible. And then replication. I have to have enough experimental units or enough participants that I could actually notice differences in outcomes. If I only test this like 2 people get caffeine, 2 people get caffeine free, 2 people get nothing, That is not enough for me to notice big trends that would be happening. Once you get this copied down, go ahead and try the check your understanding after you've gotten our big ideas. Why was it important in this situation to have a control group that didn't get a mark on their rear?
I said it was important because it helps differentiate one group from others.
We need to be able to differentiate the groups from the others. Anybody else? Yes, ma'am.
Get that to be comparative or feed out.
Yeah. So we need to be able to differentiate, and we need comparison here. Absolutely. Control group provides our baseline data so that we have something to compare to. It shows how many deaths would occur if nothing was done. Suppose that the researchers had 1,200 cows. How could we randomly assign the cows to these treatment conditions?
I said split them into groups of however many and random number generate the cows into the groups you know.
I like that. I would flip it around a little bit. I would use my random number generator first. So if I'm going to use a random number generator, what do I need to know about each of these cows? They need a number. So I need to assign a number to each cow. A lot of times cows, at least here in the US, they'll have tags that have numbers in them. So maybe they have something like that, or since they're describing that they're in Africa, for the purposes of the assignment, they could just paint numbers on them and then wash them off afterwards, right?
Yeah.
So you want to label your cows 1 through 1,200. You said random number generator. How many would we want in each group? 400 in each group. So we'd use our random number generator, come up with like 400 random numbers. That would be my first group. And then I could repeat the process for another group of 400. And then the leftovers would be my third group. So maybe the first group gets the eyes on their rear ends. And the second group that I find with my random number generator is the ones that get the crosses. Why do you think they have that condition where they just get a cross? What do you think they're testing to see?
To see if it's the eyes or if it's just the pain in general.
Yes, to see if it's the eyes that are deterring the predators, or is it just the fact that there's paint on their rear end that is deterring the predators? What's the purpose of randomly assigning the treatment in this context?
To cancel out any problem.
To cancel out any confounding. What could be some confounding variables with cows?
Size.
Age, size, maybe speed.
Yeah.
Maybe some cows are faster than others. If I randomly assign them, then I'm not guaranteed to get all the speedy cows in the eyeballs group. And then I think, wow, this was so effective. And you're like, no, you just picked out the fast ones. Or maybe certain predators are intimidated by the size of certain cattle, and that would be what's deterring them. So random assignment allows us to avoid that. What would an outline look like for a completely randomized design for this experiment? So I was looking for kind of like that mapping on this one. What would that look like?
You have your 3 groups. And what I did was, I randomly, once you get that number, you could like 1, 2, 3 a cow, and then put them. So if you got 3, you'll go to cows with nothing. If you got two, you go to cows with cross marks. If you got one, you got cow. You go to the cows with odds.
Yes. So you want to make sure that when you're drawing an outline for your completely randomized design, this should explain like all the pieces that we've kind of talked about up here. So you're going to start off with your big group of cows, your 1,200 cows. You're going to randomly assign them to the groups, whether you use a random number generator or, you have somebody pulling numbers out of a hat, some way to randomly assign them to those three groups. The three groups are going to be the same size or roughly the same size. It might not be possible to get them exactly the same size, but they're going to be approximately the same size. Each group receives a different treatment. And at the end, we're going to compare our deaths. Yes, sir?
Would the lion also be one of those problems? Because what if he wasn't hungry that day or something like that?
Good point. I'm trying to remember what it said up at the top. How long did they give them? 4 years. So I think yes, if you were only doing this over the course of like 1 day, yeah. But over the course of 4 years, I think we would help control for any of those confounding variables in that circumstance. Absolutely. So if you're going to draw an outline or if you're going to write it out in words, these are the basic components that you need to have. You need to talk about your big group. You need to talk about how many groups you're splitting it into and how you're going to do that splitting. In this case, it's random assignment. Each group receives a different treatment. And then we're looking for our response variable at the end. This right here would be our explanatory variable. Type of marking that they receive, and then our response variable we compare at the end there. Quick question. What if, like on the Coke experiment, what if I thought that the temperature of the soda also affected people? If we were doing caffeine and no caffeine, and then I thought temperature might be affecting this, I want you guys to kind of think on that and come in tomorrow with some ideas. Like if I want to test more than one thing, how could I do that without running multiple experiments? Don't forget the 4.2 homework is due on Tuesday. Sorry, you're right. You won't be here tomorrow. Think about it over the weekend. I hope you guys have a fantastic weekend. 4.2 is due Tuesday. We have an e-learning day on Thursday. I will make sure to get the test review in your hands before that so you guys can use that day to study for the test.